Hello everyone, welcome you all in C++ templates part 3. In our next videos we will discuss these three topics. First is function templates with more than one generic type, second is overloading function template, and third is function template with non-type parameter. And in this video we are going to discuss first topic, that is function templates with more than one generic type. So let us begin. Function template with more than one generic type. So in the previous programs we have defined templates that takes parameters of single generic data type. However, it is possible to define a template with more than one generic data type, and the multiple generic parameters are specified in the template header, which are separated by commas, right? Which are separated by commas. So multiple generic parameters are specified in the template headers, which are separated by commas. So let us discuss with the help of an example. So first is, we have defined a template function. Now in this purpose of this writing this function is, it takes two numbers of type t1 and t2. Why t1 and t2? Because t1 and t2 are data types that are different from each other, right? So for example, a is of type int and b is of type float, for example. So it will calculate the average of those two numbers which we passed to it. So right, so here, since the function template needs to manipulate two variables of any data type, so the function template header specifies two generic data types t1 and t2. This is the function header specifies two generic data types t1 and t2. Now the name of the function template is func_average, and it takes two parameters, one of type t1 and another one is of type t2, and it calculates the average of those two numbers, because output of integer divided by integer is integer. So if we pass two numbers of type int, for example, then integer plus integer, if we write 2 instead of writing 2.0, then it will return an integer value, right? Because output of division of two integers is again integer. So because part of our output after the decimal point will be chop off, or you can say truncated, right? So that is why we have writing here 2.0, because this is another case if we want to pass two numbers of same type, that is int. So int plus int is equals to int, and int divided by 2 will be again int, right? So after the decimal, which we have decimal part will be truncated. So but we don't want this, so that is why I have written 2.0, because integer, if suppose these two are of integer type, right, then integer plus integer will be integer, but division by 2.0, that is will be float. That is why. So here we are returning average, that is of float type. So that is why return type is float. Okay, so when the compiler encounters a function call in the main function, it replaces t1 and t2 with the data types of the arguments specified in the function call in the same order. For example, this first argument, that is 5, right? So data type of this 5 is what? Int. so int will be passed, right? And here 2.8 is of type float, so these two of same order, so t1 will be int and t2 will be float. And if I write 2.8 comma 5, then t1 will be float and t2 will be int, so order matters. Alright, so this function call creates a new version of func average and substitute int with t1 and float with t2 throughout the template definition, as 5 is of type int and f is of type float, right? And average of these two will be printed on will be returned and here we are declaring a variable a of type float. So this float value which is returned by this function will be stored in this variable a, and here with the help of printf function we are printing the average of these two numbers is percentage f, and this percentage f, this format specifier, it is replaced by the value of a, that is of float type, right? So let us run this code in VS Code. Okay, so this is the program that we have discussed. So let us run this. Okay, so let us run this. So output of output is 3.5000. so you can calculate this, right? Here I am passing 5,2 because this is a case, and if I replace this by 2, let us save and run this code. As I have said earlier that this part will be truncated, right? After decimal point this part will be truncated, and because this part will be truncated, so 5 plus 2, that is 7, and 7 divided by 2, obviously it is 3.5, but part after decimal will be truncated, so average is equals to 3 and its type is float, so 3.00 will be stored in average, and then this value is returned and this will be printed. So this is the reason why I have written here 2.0, because I don't want to get wrong output, right? Even though I have entered two int numbers. So let us change this to this. You can calculate at your home, right? So next is 2.5 and 5.1 and let's say 2.7. so let us save this and run this code. So this is working fine for when I have passed two numbers of float type. So let us suppose one is of type int and second one is of type float. So let us run this code. Okay, so output is this you can calculate at your home. Okay, so thank you so much for watching this presentation.